Okay. Okay. So today we are covering chapter 8, the first section of chapter 8, which is, so chapter 8 is the chapter for sequences and series. How many of you, just quick raise of hands, how many of you remember working on sequences and series at the end of the year last year? Do you remember what you did? Do you remember anything about it? Excellent. What? It looks familiar. That's good. Looking familiar is a great place to start today. So we'll go with that. I'm a little shocked at how much information they crammed into the first section until I realized, because to me it's like all of these very different things, but really when you step back and look at it from a non-math teacher perspective, it really is just about the patterns. So just focus on the pattern. Don't worry about fancy formulas. If you remember or recall that there even were formulas, we'll cover the formulas next time, okay? So a sequence, an infinite list of numbers, it doesn't technically have to be an infinite list. It could be a finite list. It could stop at a certain value. But the sequences that they use in this class are generally speaking infinite lists. So they've got the ... at the end. We've got, in this book, they just call them formulas. Okay, last year we would have specified that this is an explicit formula and this is a recursive formula. Okay, so I put those up here just so that you could relate it to something you've already seen. So if we had the example of the sequence 5, 10, 15, 20, we could describe that. We could say we're counting by fives. We could say go up by 5 every time. We could say, what else could we say? Any other ideas? I can't think of any. Okay, so here's that sequence, and then the formula that you would see in your Math 1050 book would be that A sub n, like S-U-B, sub, like a subscript, yeah? A sub n equals 5n, okay? One year, I specify that I'm saying A sub n because one year my students thought I was saying this. Good times. Okay, it is not A of n, it is A sub n, subscript. Okay, anyway, so if A sub n equals 5n, A sub n is just talking about the nth term, some mysterious term somewhere along the way in the sequence, okay? When I call it the nth term, that just means it could take on the first position or the second position or the 80th position or the 112th position. It doesn't matter, okay? So no matter what term of the sequence we're looking for, the formula is to take the term number, so what number it is in the sequence, if it's the first term, second term, third term, and just multiply it by 5. Does that seem to work up here? This would be the first term. Is that 1 times 5? This would be the second term, so it's 2 times 5. This would be the third term, so it's, okay, I'm boring you to tears. Okay, moving on. Recursive formula, so explicit, I could immediately find the millionth term if I really wanted to. It's 5 million. Because I can just take the million, multiply by 5. Done. Yeah? In a recursive formula, if I wanted to find the millionth term, I would have to find all of the terms leading up to the millionth term. Okay? So a recursive formula is always dependent upon what happened on the previous term. So I can't find the current term or the nth term until I know the one before it. And I can't find the one before it until I find the one before that, and the one before that, and that, and that. Does that make sense? Okay. When you define a recursive formula, it is super critical that you include this guy right here, the first term. Okay, you can tell me all day that all you have to do to get the pattern is add 2, but if I don't know what you started at, I can't write that sequence out. So when you just define a recursive formula, you say that the nth term, you describe what's happening to the previous term to get the nth term, then you have to tell me where it started from. Okay, so these are just 2 different formulas that we can use for that exact same sequence. Good? Easy? Any questions at all? Swell. Okay, partial sums. So if I take a sequence and I add up a certain number of the terms, that's called a partial sum. So for the example that we just had, can you guys find S5 or S sub 5? What would that be? Do you understand? So a partial sum, instead of just writing the list of numbers in the sequence, a partial sum is saying add those first 5 terms of the sequence together. So the first term of the sequence was 5, the second term was 10, 15, 20, 25. So here's A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. S sub 5 is just the sum of A1 through A5. Add them together, and we have our answer. So what's that? 45, 60, 75? Good? Later on, we'll get formulas, so we don't have to do that by hand, but that's the idea. Any questions at all? Swell. Okay. Sigma notation. Does this look familiar? Yeah? Can you describe these parts to me? Anybody? Okay. So this is the term that you start at. This is the term that you end at. So I'm going from the first term to the nth term. And over here, this A sub k, this is just saying term number right now, like, or term value right now. So this would be A sub 1. And the sigma is telling you that you're adding them. So this would be A sub 1 plus A sub 2 plus A sub 3, all the way until we get to A sub n. Most of the time, what you'll see is a formula right there. Okay? So as an example, let's try. I don't know why that was so large. Okay. Can we do that? Yes. Doesn't matter. You can use any letter you want. That's why I wanted to start immediately using whatever random letter popped into my head, because it doesn't matter. Okay? It does say that n starts at 1, and there's an n in this formula, so that's going to be important. No, actually it's not, because you will definitely come across this. I don't know why. I honestly don't have a clue why they wouldn't just match those 2 letters up. Sometimes they don't. Yeah. Jerks. Okay? Anyway, so let's do this one really quick. So if I need to add the first term through the 7th term, in order to do that, what do I need to do? What's the first thing I'm going to put in my sum? 1 plus 3 is going to get added to 2 plus 3. And we're going to add that to until we get to is that pretty straightforward? Okay. So you would actually do it, not just write it out. Yeah? Okay. Easy? That is it. That's your lecture. That's all you need to know in order to do your assignment today. So your assignment today relies heavily on just formulas like this. Okay, the first section on the homework is just find the first 5 terms of the sequence. So it'll give you some random formula. So to find the first 5 terms, you just plug in 1, plug in 2, plug in 3, plug in 4, plug in 5, and then we'll ask you for the 100th term. So what do? Do you have to find the 6th, 7th, 8th, 9th, all the way to the 99th to find the 100th? No, that would only be the case here in a recursive formula. Okay? So it'll have you fill in tables on your assignment. The summation notation or the sigma notation, same thing. There will be fancy formulas here. Okay, not formulas that you guys can't handle, obviously. Okay, and just remember the difference between like an A sub n and an S sub n. If you ever see S, you got to think what word? Sum. Okay, S sub anything means add all the terms until you get to that number, whatever that term number is. Good? Okay. All right, I will let you get to work and then just let me know as you have questions.